Hey, what's up guys? Welcome to C++ in 2021. So as the title implies, today we are going to look into socket networking and making a basic TCP IP client server application. We're not going to get too deep into it today. We're going to build the scaffolding out and then we will expand upon it next time, because this is something that will be ongoing. As I was looking for a larger project to base our C++ lessons around, and this will be a good example because we can branch off into doing stuff like HTTP connections, and we can expand our threading to, instead of being a single thread, we can do thread pools with this, and there's a lot of things we can do building out a server. Servers can be pretty chunky applications that we can really put as much work or as little work as we want into. We're going to be switching from Visual Studio C++ to CMake based project. I'm personally going to use CLine, but you can use any other CMake based application. If you don't know how to do that, check my game engine series above. I believe I show how to do it in Visual Studio Code, but you can do it as I show you today in CLine. That being said, let's just jump into it and hopefully we have a good time doing it. Hit the like button. All right, so let's just jump in and start building out our application. So as I said, we are going to do this in CLine, but you can use any compatible CMake editor that you would like. So I'm going to click New Project. I'm going to make an executable for now with the C++ 20 standard, and we're going to call our project Mud on Your Face, and that's going to be the name of our game. And you'll see that we've got a very basic program with a CMake list here. Now, the main issue that we're going to have here is that we do not want to have the server and the client be the same application, but we want to be able to work with them within the same project. So what we're going to do is we're actually going to move these main.cpp out into their own folders. So we're going to hit New Folder here, New Directory, and we're going to call this Mud on Your Face, Moif server, and we're going to make another function, New Directory, Moif client. And then we will actually move this CMake list into Moif client here. We'll do that. And here we're going to change this to Moif client. And we will copy these actually, and we are going to paste them in the Moif server. We'll make this Moif server like this. And here we're actually just going to change it to project name so that we don't need to worry about renaming it. And we'll do the same thing here. All right, so we have two applications here, Moif client and Moif server. Now this is not going to load properly. Notice how there's no configurations up top because we need a parent CMake list. Oops. So we're going to right click here and we're going to hit new, and we'll say CMake list.txt. And we're going to go here and we're going to copy this project here. It's going to be project Moif client. And what we're going to do, we're just going to add subdirectory Moif client, and we're going to add subdirectory Moif server. Moif server. And if we reload those changes, no CMake minimum version required. So this doesn't show up here, right? Oh, yes, it does. So we will add this here as well. And we will reload these changes and finish. Now you'll notice here, now we have both of our client and server here. And if we want to run them, let's just say hello. This is the server, hello server, and this is the client. So we'll say hello client. And if we play that, you'll see it builds, it links hello client. And if we go to the server, we got hello server. So we've got our two applications. Now we want a library to share between them. What we're going to do here is we're actually going to make another folder, and we're going to call this Moif networking. And in here, there's going to be one more CMake list. And let's just copy this as a base. And what we need to do is we want to say add library, project name here. And we are going to add this subdirectory up here, Moif networking. Because another target, right, if you go here, we want to change this to Moif networking as well. Moif networking. There we go. And now if we build all of this, oh, there's no main.cpp. That's fine. So can we build this now? And no sources. That's fine. Well, we can deal with that in a second. So what we want to do is our library, we want the same structure as we had before. We want a source directory, and we want an include directory, and include here. We're going to call it Moif networking. And then just to be, as to have an example, we are going to create a header file here. We'll say moifbase.h, and we are going to create a new source file here, and we'll call this moifbase.cpp, and this is going to include Moif networking / moifbase.h. And actually, we're going to rename this to, we're just going to call it base.h, and we're going to call this one base.cpp. Okay, so this will still tell us there's no sources, so let's fix that. So we've created our library structure like this, and what we want to be doing is being able to use our base.h file within our client and server. So what we need to do is, what we'll do is we'll quickly make an enum class and call it my enum, and we'll just say 1, 2, and 3. Now we want to be able to use this enum inside here. So I've already included the base in this file. So let's just say void. Yeah, let's just do this, and we'll just hopefully we'll be able to include this networking file inside our project. Now to be able to include this networking file, what we'll do is we are going to target include directories is what we want, and we'll do it by project name. And we are going to create a public section here. And what we're going to do is we're going to go to our YouTube game engine, and we're actually just going to copy what we had in our engine library here, which is our install interface include and our build interface include. And we'll add those to here. And let's do this. We'll reload this. Now, if we go inside here, you'll see that now it works. So in our top CMake list, notice how we added Moif networking first, and then we added the second ones. I believe that's important because these two are going to rely on this top one. So in our client, what we're going to do is we are going to say we want to be able to include Moif networking base.h, right? That's our goal. Now it's going to show a red squiggle. All we need to do for that is first we're going to say target include directories, project name, again public, and we are going to just add Moif networking here. And we also need to add target link libraries, and again project name public Moif networking here. Now that should be enough. Let's reload this. You shouldn't get any errors from CMake when it reloads that. And when you rebuild your client, you'll see it builds. And if we go inside here, this include turns gray. And what we can just say here is we can say cast this to static, cast integer thing, my enum 1, right? Now we can do the same thing for our server. So we can take, we can basically just copy this and put it inside our server like this. And we don't want to add these. And let's fix the indentation here. fix it here, and reload those changes. And we can do basically the same thing inside our main.cpp. Oops, and just do that. And we are going to do enum2 just to be thorough. So if we hit play on that, you'll see it prints 0, which is enum1. And if we go to our server and play our server, we get 1. So with our basic project set up, our next step is going to be to include the libraries we're going to use into our application, which is going to be the Boost library. So if you look, if you go to boost.org, you'll see right at the front page there's a current release button with version 1770. Click that button and download it. I've already done it. Then, once you have it downloaded, you'll want to extract it somewhere. I personally put it in my source directory here. Under libraries, I have Boost 1770 here. So in order for CMake to find our Boost library, we're going to need to define some environment variables for CMake to look up in order to find Boost. So I'll show you how to do it on both Linux and Windows. On Mac is just a tiny bit different. So on Linux, if you go to Ubuntu, I have an Ubuntu box here. You're going to want to set it inside your bash RC. So you'll want to do like nano, which is a text editor, your home directory .bash RC. You'll get a file like this. You go to the bottom and you do something like export boost root equal, and then path to boost, and then 1770, like that. And that's how you would do it. You would then save your file, which is Control X and then Y, and then enter. And then you would need to relaunch your editor. So relaunch CLion, close it down and open it up. On Windows, we've done this before. You can hit the Windows key to open this. Just type in environment variables. You'll get edit the system environment variables. Click the environment variables button. And I've already done it, but here you would click new. You click new variable name, which would be boost root. And then variable value, you would browse directory and find your boost directory, which is what I've done here. And again, if you set that up and it wasn't already set up, you'll need to shut down CLion and restart it, which I don't need to do because I already had it set up. So now with your environment variable set, all we need to do is find the package and add it to our library. So what we will do is here, let's not have that. We'll say find package. We'll say boost. And then we put in the version, which is 1.77.0, which is ours. And then we put required. So with that done, we're just going to add them to our project. So we're going to add a private field here, and we are going to put the environment variable boost underscore include dirs. And then we need to create a target link libraries, which is also going to be project name. And let's see, project name. And then this will be, again, we'll put private because we don't have anything public right now. And this will be boost libraries, like this. And that should work. So let's reload those changes. And everything builds okay. Now, if we go to our base.cpp, we got our enum. Let's make a function, right? Just to test out our integration. So we're going to use the example that's given to you on the Getting Started docs from boost.org, which I'm just going to paste in here just to check everything. So the first thing, we're going to bring in some stuff. So we'll bring in these files here, and then we are going to create a function void multiply by 3, and we are going to just do this here. Now this is not a big thing to put inside the library because it blocks and all sorts of stuff, but we can do that, and then we should be able to build. And if that doesn't work, we can figure out why. So this doesn't work, cannot include lambda, because now this is normal, because notice here how our public interface has these, but Boost is private, right? So what we want to do is we want to make this an interface. Let's just copy this. We'll make this an interface here. We'll delete this. We will move it to base.cpp. And we will actually just move all these includes into base.cpp as well. Now that should be much better now. We should be able to build. Good. Now, let's do it in our server. We're including base.h, so we can call multiply by 3. And what this will do is it will wait for a number, and then it will just print out that number multiplied by 3. But let's just put a new line in here, right? So let's hit play on that. It's going to build our server. So it's waiting for an input. We take 3, it prints 9. Put 4, it prints 12. Print 19, it prints 57. And that's exactly what we want to do. And then we can quit that by hitting the stop button. Okay, so with our Boost libraries in place, let's start building our client and our server. Now our server itself, it's going to start fairly simple. What we want to do, first what we're going to do actually is we're going to make these Boost includes public, just so we can start building stuff out, and we'll start abstracting things out as we can, and hopefully we won't have any Boost things left in our main server places. So with that in the public, we should be able to include our Boost ASIO here. So include Boost ASIO.hpp, right? And let's clear out our library for now. Let's clear out our library because we don't want to have this for now. So close that and remove this and remove that. Oh, that's fine. We can no base, no include IO stream. All right. So we've got our Boost ASIO, right? So the first thing we're going to do is we need to open a input output or an IO context, a Boost IO context. So we're going to wrap it in a try block for exception handling, which we're actually going to look into in a future lesson where I'm going to go into more detail on exception handling. But we're going to wrap it in a try block. We're going to call Boost ASIO IO context. And we're going to call it IO context, because why not? Then we need to create an acceptor object that will listen for connections, incoming connections. So we will say TCP. Right. So if we need the TCP object, but it's under Boost ASIO IP TCP, right? So what we're going to do to make it a little bit easier on ourselves, we're at the top of this file, we're going to put a using here, and we'll call it using here, and we'll call it TCP. We don't even need the TCP. We can just do that. And then from here, we can say TCP acceptor, and then we'll call it acceptor, and IO, give it the context we created, and then we give it our endpoint. We give it TCP, we give it a v4 endpoint, and we give it the, I believe it's the port number, if I recall correctly. With that, we create our acceptor, and we want to go into an infinite loop. So we can do either for like this, but I personally like while true. And then we'll do TCP socket, because we want to create a socket, and we again give it the IO context. Then we accept a connection on that socket, acceptor.accept on that socket. Now what that will do is that it'll wait. I believe it blocks here until it gets a connection, and once it gets the connection here, it will put the information inside that socket. So then we want to send a message back to the client that connects. So we'll make a std string, and we are going to say hello message, and we'll say hello beautiful client, and we'll just give it that. And then we are going to give it we have to give it an error return. So if we give it boost system error code error, we can say boost ASIO write. We write on the socket, and we give it a boost ASIO buffer of the message, which is the hello message. And we give it the error that we want it to populate. Then we want to catch an exception. So let's say catch std exception and E. And then inside here, we will just put it out to here. Now this should work. Now, why is it giving me red squiggles? Right, that's where I want to put it. I just put the catch at the wrong spot. Yeah, so let's include IO stream and build that. Now I don't know why I'm missing so many squiggles. Okay, reloading the CMake project forced everything to update itself. All right, so that is our basic server right there. Now all this is doing, going over this again, yeah, it's making an IO context, which is just a context object that Boost uses to keep information on your input-output for your system, I imagine. You're creating an acceptor to accept connections, and then with your acceptor, you're waiting for a connection and storing that connection in the socket. And then once you have the connection, you are writing to that socket. And then when this goes out of scope, when it goes back around, socket falls out of scope. So we'll actually close this socket. I believe in the socket destructor, it automatically closes. So if we look at that, let's just say here we'll put a std count accepting connections, right? And we'll put a new line. Oops. Having trouble typing today. Put a new line there. And here we'll say on port 1337. Now this is the port number that we want to give here. There we go. So this will accept connections on port 1337 and using IO context. Now I don't know how v6 would work, but we'll look into that again further. So if we play this, you're going to notice it doesn't really do much. It's going to say accepting connections, and then it's just going to block there. We'll allow access, and it just blocks on accepting connections on port 1337. Now with that out of the way, we're going to just start our server here, and it's running. Actually, what we will do, we'll make one more change to it. We'll say here std count client connected sending message, just so we can see everything that's happening, right? So let's build this. And anyways, so we've got a server running. Now let's build our client, which will just receive this message and close. So we're in our main.cpp here. Now, what we want to do for our client is going to be a little bit similar, but different. So first things first, we are going to also want our boost /asio.hpp. And what are we going to do? The first thing we're going to do is we're going to expand this to get arguments. No, we're going to skip the arguments for now, but we'll put this in here just because I want it for later. Arg v like this. Now let's take this and I also put it inside our server just for posterity. Now similar stuff. We'll hit try here, and we'll put our catch here. Stood exception E there. Okay, so we have our try catch block now inside here. We'll switch this to client just so we don't do it by accident. Now, what we want is we want to again create our IO context. Boost ASIO IO context. We're going to do this a little bit more my style now. We're going to create a TCP resolver, which is kind of like the equivalent of the TCP acceptor, except for it makes connections, right? So resolver, and we are going to give it the IO context. Now we're going to do this, start doing this in a lot more modern way. So we'll do it like that. Now the resolver, it takes a host name. We want to also using Boost ASIO TCP or IP TCP, like that. Now we want to get a list of endpoints for our resolver to connect to. So what we want to do is the first thing we're going to do is we're going to say TCP resolver results type, which is what it's going to return, endpoints equal resolver.resolve. Now here we're going to give it the IP that we want to connect to. So in our case, we're going to do localhost, and then the port or the service that we want to connect to. Now we gave it 1337 like this. And here actually what we're going to do is we're going to change this to auto because yeah, why not? So with our endpoints created, we want to create a socket. So TCP socket IO context. And then with our socket, we want to connect. So Boost ASIO connect socket endpoints. So I misspoke earlier. The resolver is to resolve the possible endpoints for this, apparently. So what we will do now is we will just listen for messages. And this is not working. Why does that not work? Oh, IO context first here. Oops. Well, that's what I did wrong. Socket endpoints. And then we can do that. So I just forgot to name it my socket here. All right, so with that out of the way, we have connected to our socket, and we will listen for messages. So we'll hit while true. So first we define a buffer. Now the example is using boost array, but I would prefer to just use the standard array if possible. So we will say include standard array, and we'll say std array character of 128, and we'll call it buffer, right? Then we will say boost system error code error, and if we do size t length equal read sum over boost ASIO buffer error. Now if error is equal to boost ASIO error end of file, that means that we have successfully we've received a clean shutdown. So basically if we receive end of file from boost from our socket, that means that the server has cleanly cut the connection. So we just break here, and we'll just put a clean connection cut off. And then otherwise, we will throw a boost system error. And then finally, we will std count.write and buff.data of length. And we will include IO string with that. And then again, we will do the same thing we did inside here with our error. I don't feel like typing it again. We will do this here. Now this is telling me it's unreachable, which is not, right, else if error. So if the error is nothing, then we will build it. So let's build our client now. And in theory, it should print off our hello beautiful client. So if you look here, what we're doing, again, we create the IO context. We create a resolver to resolve the host, to create a connection string basically, or a series of connection strings. Then we create the socket and we connect to the socket. If the connection to the socket is successful, I believe this will throw an error if it doesn't connect. But anyways, if it succeeds, it will listen for messages and print them to the console. Otherwise, if there's an error, it will quit. And that's all we need. So let's watch our client and see what happens. And hello beautiful client. And if we look at our server, client connected, and then it starts accepting connections again. Now if we change this to a different port, what happens if it can't connect? It will, no connection could be made because the target machine actively refused it. And that makes sense. Now if we take this and it just doesn't, there is just no machine, it should give a different error. Yeah, basically no connection could be made, so it went to e.what. I imagine that this is where it's going. Let's just oops. Let's stop this. Turn this off here. Now I imagine that this is where it's going. Yeah, and it goes straight to the catch block here, and that's where that's where that gets printed. Right. So now let's make this a little bit more interesting. What we're going to do is, you'll notice here that this is all inline synchronous. We're going to make a asynchronous client using the Boost library. So we're going to actually do this inside our library itself, and then we're going to move stuff over. So the client's going to stay the same for now. It's just going to listen for messages, and we'll probably move this out later. But in the case of our server, that's where we're going to make the biggest change. So the first thing we're going to do is we're going to say new C++ class, and we'll just say server. First, we're going to create a settings file. We're going to create this to snake case like I like it. And we're going to say server. It's going to be a server class. Right, we have a server class, server.cpp. We're going to move this. Oops. I'll do this. Refactor that. We're going to delete our base files. Now I believe it's adding stuff into one of these CMake files. Oh, maybe not. Yeah, it added it to here, which I don't want because we're globbing stuff. Okay, and we'll reload those changes. All right. So we've got our server class. We're going to wrap it in a namespace, and we're going to call it moif. So the first thing we're going to do is we're actually going to rename this. We're going to say TCPServer. We're going to name this, this got renamed automatically, and we're going to rename this TCPServer as well. And we're going to rename it one more time, and TCP will be all caps because that's what I want. We'll make our public and private sections for now. So what we want to do is we want to have a TCP server constructor, and what this is going to take, it's going to take we're going to want a port, and we're going to also want the TCP version. So we are also going to say we're going to create our own enum class here, and we're going to say it's going to be the IP version, not class enum. It's going to be enum class, and it's going to say v4 and v6. Now we could use we could use base boost constants for this, like we did before. If you look here, we passed in TCP v4 here, but the idea here is that this way we can abstract it out and possibly switch out our networking backend in the future if we see fit. So the first thing we are going to want to do is our TCP IP version. So it's going to take IP version, and it's also going to take a we'll just say a std string port, and we'll include that with our we'll include that, and that will be our constructor. Let's just start with that, and we'll work our way through. So the TCP server constructor will store, do we want to store it, or do we want to just, here, we actually want to namespace moif this, do that, and then we can get rid of this, and I think we can get rid of this too, right? Yeah. That'll make it a little bit easier to read. Do we want to store it? Let's just store it in case we want it later. So IP version, and then we'll say std string port. And then we can go into our thing here, and we can say IP version is going to be IPv, and then port will be std move port, right? And port's never used, but that's fine. We can deal with that later. Now with that done, what we can do now is we can actually create our IO context. So if we go inside our TCP server, we also want to create our Boost ASIO IO context. Do that, and we will import this by, no, we don't want IO context, we want include boost /asio.hpp. That's what we want. So we want the IO context, and we also want to create the acceptor, which we can do at this point. So boost ASIO acceptor. No. So here, what we'll do is, again, inside this will just be in here using boost ASIO IP TCP, and we'll say. All right, well, you know what? We'll fully qualify it. ASIO IP TCP acceptor. Now, if we go to our server, we can now initialize these things as well. So our IO context is just going to be a new IO context. So yeah, I'm working on it. So acceptor equal boost ASIO IP TCP acceptor IO context. Oops. IO context, and then which will be Boost ASIO IP TCP endpoint, and then so we're actually just going to be using that here, because I don't want to have to type this all the time. IP TCP like this, and then we can IPv equal EB before and TCP before else TCP v6. Oops. Okay, and port. Now what this is still complaining about, must explicitly does not have a default constructor. So I guess I need to do it like this. And do it like this, I guess. Now why is this complaining? Oh, this should be an integer. So this will actually be an int port. Then this will be port is port, and TCP server is not a string, it's an integer. And we can remove string from here. Now will that be right? And change this to int. I know this is kind of insane, but there's no default constructor on acceptor, so we have to build out the acceptor here. Now I might be able to just remove this as well. Yeah, because this is basically a constructor. Here. Now let's build this. All right, so we've created our TCP server. We might have other stuff to do in there eventually, but what we want to do is we want to be able to start accepting. Yeah, so we will also create a function called run, which will run our server. So we will say void run. So we'll create a void run. Now what void run will do, it will actually just run our IO context. That's what we want. We want to IO context dot run, and dot run is a blocking method, so this will block as well. So basically until run exits, it's always going to work. And we will actually say we'll actually make this return int. Here, let me see, top server, we'll make this int. And we will wrap all of this inside a try-catch block. Exception E, and we will copy the same thing here. TCP server, do this, and we are going to return -1 here if there was an error. Otherwise, we will return 0. Right? So that will make our TCP server run, and we need an IO stream here. Include IO stream. Okay, so with that done, we have a few things left to do. So run will run the context, and we will, so we will set up a few things inside here. So with our acceptor created inside here, we are going to set up a few asynchronous things here. So we are going to create a private function here, which we will put in a separate section. Oops. And we are going to say start accept. Now what this will do, sorry, there's a spider on my monitor that I need to kill. So this will be a void start accept function, and we are going to generate this. And what this will do, we will call start accept from, and we will call start accept from here. Now what this is going to do is it's going to create a connection. So let's say TCP connection. No. So we want to create a connection, and then we want to asynchronously accept the connection, right? Yeah, we're going to need to create the new connection now. So let's do here, we're going to say a new C++ class, TCPConnection. We're going to namespace this one as well. Then we will we'll move this to our source here. We will add the namespace here and remove it from our CMake. And we will reload these changes. So our TCP connection, what's it going to do? Let's add our private labels like this. What's it going to do? So our TCP connection is really just a glorified socket. So again, we will use the TPC here using Boost ASIO IP TCP and include Boost ASIO.hpp. Then we will create our socket. So TCP socket. And we are going to create the message that we want to send to the client when it connects. So message equal, so string message, and we'll do this. And our message itself will be the same message we had here, just so that we have the same thing going on. So TCP connection dot h, the message itself is going to be the same here. Oops. There you go. And then what do we want to do? We want to be able to get the socket of the connection here. So we will say TCP socket and socket return socket. And then what else do we need? We will start the connection, which will write the message. So for now, we'll just write the message, but we'll write start. And here we'll put socket. And yeah, that's fine for the getter. Let's move this getter up. But void start will be its own function inside here. Let's go back. And right, we want to create TCP connection constructor, which is going to be private, and we are going to provide a create a factory method, basically, specifically because we want to make sure that these are all shared pointers and will fall out of context. will fall out of context when they go out of scope properly. All right, so that's enough for now. Let's generate a definition. I don't want to do it in place. Okay, we'll bring this up. Now I could have done it in place, but I like having things a little bit cleaner. Now the constructor for this will have, it will mostly just be initializing our socket variable to take our IO context here. Like that. And our start method is going to basically just write out to that socket. So ASIO async write. And now this one takes a socket. It takes the message that you want to send. So in our case, it's message. And then it will take a binding to a function. Now, what I'm going to do is I'm hoping that this is going to work, that we can just make this a lambda for now. Oops. Yeah, why not? And this should be, it's going to take a const boost system error, and it's going to take a size t bytes transferred. Now message is not defined. Why is message not defined? Because I didn't put that there. Let's do that. Boost system error. Error code, whoops. Error code. I do this. And this would be socket like this. There we go. That worked out. All right, and then we're going to say std count if error failed to send message, and otherwise else std count sent bytes transferred bytes of data, and we do that. All right, so with that done, we are most of the way there. Let's look at the std count. I need IO stream. Okay, so last thing we need to provide is a factory method for creating these TCP connections. So there might be another thing that we need to. No, I think that's all we need to do. So to create our factory method, first we're going to define a pointer type. So now we want to always reference our connections as a shared pointer, so that if they go out of scope, they only get destroyed if there's no more references to them. So we're going to say using pointer equal std shared pointer TCP connection. Now with that, we probably want to include memory, I imagine. I think that's where a std shared pointer is. And from there, we are going to say, we're going to provide a static method, static pointer create, and it's going to take a Boost ASIO IO context reference, and it's going to return a pointer to new TCP connection, IO context, like that. Now that should work. There we go. And now why is this yelling at me? There, it's implemented. Good. And that is our TCP connection class. Now what this single argument constructors should be marked explicit. Sure, why not? Just to shut it up. Now, with that done, I think that is everything we need. Yes. We can go back to our TCP server and finish what we were doing. So we were inside our async accept here. So our connection here is actually going to be a TCP connection dot create, which should be here, IO context, like that. And this will be, we'll just say auto, like this, right? And we can import that. And this will give us our shared pointer TCP connection. Perfect. Now our acceptor, async accept now, the first, if you look at what we did with the write, if we look at our TCP connection with our write, it takes a socket and then it gives it a buffer and then it gives it a callback, right? So it's going to be similar here. It's going to, you're going to give it a socket, which is going to be our connection socket. Then we are going to bind a function that will handle accepting other connections. So again, we are going to pass in this, and this one will take a, it's going to take a TCP connection pointer, and it's going to take the new connection, and it's also going to take an error code, const boost system error code and error, and that will look like that. Now that should be appropriate. Now what's this complaining about? Now why is this? So I think what I want to do possibly is to go back. So I think it's going to be Boost ASIO system error code error, like this. Is that right? Yes. And then we want to capture the connection here. And this. And then we will say if not error connection start. And then we start accepting a new connection. Right? Now I think this is what we want to be doing if we're doing it in Lambda like this. Right, good. Now in theory, this should be basically all we need to run our server. Let's get rid of the to-do. IO context, I'm just looking over my notes. Shared from this, that's fine. Here. Inside here, this can we do shared from this? Can we do std shared from this? So we want so what we want to do is in our TCP connection here, we are going to say public std enable shared from this, right? TCP connection like this. And then in here, we might be able to shared from this. Will that work? Okay, so what we want to do then is, so we want to make this follow our shared pointer. So we're going to do auto strong this equal shared from this. And we are going to say strong this. And that's all we're going to do. And now if we want to use any, we can actually get rid of this. Actually, we don't want to. No, we do. We'll get rid of this so that if we want to do anything on our object now, we want to do it from the shared pointer. Yeah, so you want to do it from the shared pointer. So there's no point including this. So this way you explicitly use this strong this, right? So that's what shared from this does. It makes it so that you can create a shared pointer within yourself, pointing to yourself basically, and use it within places to ensure that you are reference counting when you're going kind of out of scope and back into scope and stuff. Right, so now let's let me look back through. I think that's pretty much everything. Our TCP connection looks done. Our TCP server looks done. And now we want to look at main. So let's look at our main server here. Now we can get rid of pretty much all of this here. Now we're going to extend our server object to be more dynamic in a minute. But for now, we want to say, include moif and TCP server. Now we are going to say TCP server, and we want to give it, I believe it's going to be TCP server. We want to give it a IPv and a port. So, So we want to say, I'll say moif TCP server equal moif IPv4 and 1337 like that. That should create. That creates our server like this. Now we want to just run our server, right? Dot run. That should create our. That should run our server. TCP server and run. Good. Now that should do it. Let's see what that does when we run our server. Let's hope I didn't make any mistakes along the way, because I'm kind of adapting this as I go. Right, so I have nothing here. Now let's go to our thing and let's look to our client. And let's open the client. Oh, that's no fun. Let's open a terminal and run our client in here because it closed automatically. An attempt was made to access a socket in a way forbidden by its access permissions. Weird. Or let's just see what my client is doing. Oh, 1337. Let's build the client. And let's try running that again. I don't think I would need sudo to connect to a server. That seems odd. All right, let's see. Hello, beautiful client. And there we go. So that worked out exactly as we wanted it to. So if we look here, this is still running. Send 25 bytes of data. And if we continuously connect to it, it will send the 25 bytes of data. Now, so with that, you can see our server is doing exactly what we want it to do, but the main issue is that it's not keeping connections open, right? So in order to keep connections open, we have a couple of options that we can do. The most obvious one would be to make sure that our connection here doesn't go out of scope. So when you create it here, it's going to reference count to 1. When it goes into the acceptor async accept, it makes a copy here, reference counts to 2, and then immediately exits the start accept function, which reduces the reference count back to 1 because this falls out of scope. Then when async accept is called, it will call this function, which will call connection.start, which will call here. It will run this, which will run the function, and it's creating a shared pointer from this, so reference counts to 2, and then it exits the start function. Then the start function returns to here, and it creates another accept, but then it immediately falls out of scope, which reference counts back to 1 because TCPConnection is still running, waiting to finish writing. And then once this finishes writing, it will reference count to 0 and destroy itself. So that's the reference counting going on here. So in order to keep our connection open without letting it just fall out of scope and destroy itself, the best way to do it is in our TCP server. When we create our connection, we should create a reference to the connection, right? So if we go to TCP server, we can create a vector here, std vector TCP connection connections, and we'll initialize that. Now we don't have the TCP connection in scope here, so let's move this to our header file here. Now what we will do is we'll say connection dot connections dot pushback connection, and then we will actually fix this here. This will fix itself. Now if we build this, what we've effectively done now is added one more reference count to it, which lives inside this vector. Cannot convert to constant. Right. I did that wrong. If I go inside here, what we actually want to do is we want to do TCP connection pointer. So we want to pointer to the TCP connection. Right, so let's build that. Now this will keep connections open now. Is this still running? Yeah, let's turn this off. This will keep connections open until this gets cleared. So if we run this now, oh, I'm running client server. If we run the server now, and then we run the client, you'll see that it doesn't actually quit. So you'll see it sent the 25 bytes of data, but now it's still running, right? And it's going to run indefinitely because we don't have anything going. And that's the beginning of client. Right, see, and then our client died here. Let's try this again. Let's hit server. Server will be running. Then we will start our client. And if we kill the server like this, this is still going, but you'll notice here that this connection is probably still there. And we can do that over and over again. We can connect more clients, and we'll continue going, but the connections vector is still going to be active. Okay, so to check if the connection closed, we should be able to do connection. We grab the socket from the connection, and then we will async receive. And then we need to get a buffer, so we can say Boost ASIO stream buffer, buffer, and then let's say buffer.prepare, let's say 512, and we will give it a this and const boost system error code error size t bytes transferred here. And then here we will say, I believe it's going to be similar to here. And it's going to be like this. And it's going to be TCPServer, like, oops. Copy this and put that inside our TCPServer. And here we should figure out no break here. Should count client disconnected properly. Now I think this should be roughly what we need to do. Let's see what this tells us. The file handle supplied is not valid. Right. Okay, so maybe we need to move this to, we can take this exact same thing and move it to TCPConnection where it says start. We can probably do this, and we can change this to socket, and then let's just see what this does and see if this gives us closer to what we're looking for. Okay, that looks okay. Now let's run the client. Hello, beautiful client. Close that. And an existing connection was forced to be closed by the remote host. So we don't want to throw this because that's shutting down our server. We will say client disconnected in bad way. All right. And now let's do this again. Good. And now let's do our client. So connected, stop, client disconnected in bad way. And then we can do something with that, probably like call a callback or something like that. But with that done, we are going to call it a, I guess, morning, because it's quite late for me. And we will move on to actually doing the handshake in the next video, because I think this is enough to get started with, and we've gotten quite a bit done. We've got a nice little client server thing happening here. The enhancements we can make to this moving forward is our server here right now is, you can see it's doing, if you look at our connection here, the connection itself is just on all the connections, it's just sending a message and waiting for it to be disconnected. So these messages here, we're going to want to properly handle messages that come in, but also we want to be able to dynamically select what we're going to write to this. So this this here will be, we will probably write a function to be able to do this for us. So we'll probably add an interface here. Let's just add the interface for now. Let's just say void write to connection and then int connection index. We'll want that. We will want to, and then we'll probably say, well, for now we'll just do string message, but odds are we'll probably want to do something like template, type name t, and this will be t message, right? Probably like that. That's probably how we want to do it. We want to be able to write to the connection. Then what else do we want to do? We want to be able to receive void register listen callback. And again, it's probably we're probably going to want to do something like template type name t, and then we'll do like int connection index and const and then we will want to have a using like template type name t using using listen callback equals stood function t, not t, it would be like void t, right? So it's going to be a function that gets called with a message, and it'd probably be like this. And we'd want to include functional. Oops. Right? Something like this, and then we would do like listen callback t callback. All right, it would be like this. Yeah, and then it would be like this, I believe, and we want to do that, right? And it'll be something like that, where we will have a interface for writing to a specific connection. We will need to figure out how we're going to store the connections smarter than just a vector, probably. And then we would want to register the listen callback here, which actually it would probably be int like this, right? And then we would just register the listen callback for that type, a message like this, and write to connection const t. This makes sense, but we would probably, either way, we'll do this in another video, but this is what I'm thinking. We're going to have an interface where we're going to be able to register listeners for each individual type, so that when that type is read from, a message is received from that type on a connection, it would send it back to the main application, where it could then be handled and any responses given. Yeah, it's something like this, but we'll deal with that later. But for now, I'll just generate these definitions so that my warnings go away. They're not being used, but if I can probably build everything now. All right, so I know I said I was trying to keep it shorter, but you know how it goes with me. Everything seems to be really long processes because I like to make things overly complicated. For better or for worse, you're getting the overly complicated versions. So anyways, if you liked what we're doing here and you're excited to see more, excited for our server to get a little bit more mature and do a little bit more of exciting things, stick around. It's just going to be another 4 weeks probably, because you know I'm going in order. I got 1 topic per week, 4 topics per month, and that's the schedule we're going to stick to. So anyways, it was fun. I'm looking forward to expanding this even more. Peace.